Now let's actually continue with this additional problem. So this is actually a word problem. It's related to the dynamic understanding towards the mean value theorem. So the problem states as follows. At 10 o'clock 17 minutes a.m., you pass a police car at 55 miles per hour that is stopped at the freeway. So you pass the second police car at 55 miles per hour at 10 o'clock and 53 minutes a.m., which is located 39 miles from the first police car. If the speed limit is 60 miles per hour, can the police cite you for speeding? So in order for the police to cite you for speeding, all he needs to do is to prove at some point your speed is above 60 miles per hour. And this can be achieved using the mean value theorem. So within 53 minus 17 minutes, so this is going to be equals to 36 minutes. And 36 minutes equals to 36 divided by 60 hour, which is going to be 0.6 hour. So within 0.6 hour, so you traveled 39 miles. So the average speed equals to 39 divided by 0.6. This is actually divisible. So this will be 13 divided by 0.2. And 13 divided by 0.2, this will tell you it will be 65. So your average speed will be 65 and the unit is mile per hour. So the mean value theorem will tell me that there is 6 times c between 10:17 a.m. and 10:53 a.m. when your instantaneous speed is 65 miles per hour. So the police can cite you for speeding. So that will be the conclusion. Although I seriously wonder whether the police nowadays really understands mean value theorems, but at least mathematically, the police has a reason to cite you for speeding. All right, so this concludes the additional problem. Okay, so we are left with 2 problems, number 6 and number 8. Let me work out these problems real quick. So yeah, hopefully not to make this supplementary video too long. Okay, so in this problem, you are asked to verify the function f of x defined on -2 and 2 to satisfy the 3 hypotheses of the Rolle's theorem on the given interval. Then you are asked to find all numbers c satisfying the conclusion of the Rolle's theorem. Okay, remember that the 3 hypotheses of the Rolle theorem is first, f of x is continuous, and second, f of x is differentiable, and third, f of -2 equals to f of 2. Well, but then the continuity and the differentiability simply follows from the fact that f of x is a polynomial function. So since f of x is a polynomial function, so f is continuous on -2 and 2 and differentiable on the open interval -2 and 2. All right. So then moreover, let's check that if f of -2, and let's see what that is. So f of -2 will be -2 to the cube, -2 times -2 squared, and then -4 times -2, and then finally +2. So what I will have is going to be -8, -8, +8, +2, and the answer will be -6. Then f of 2 is going to be equals to 2 cubed -2 times 2 squared -4 times 2 plus 2, and then, well, the answer will also be -6. So in this case, f of -2 equals to f of 2. So that way, Rolle's theorem's conditions are verified. So Rolle's theorem apply. So now let's actually see what are the numbers C satisfying the conclusion of the Rolle's theorem. So Rolle's theorem applies to C that there resist C in -2 and 2 such that f prime of C equals to 0. So in order to find out the numbers, all you need to do is to solve the equation f prime of x equals to 0. So what is f prime of x? F prime of x will be 3x squared minus 2 times 2x minus 4. This can be simplified as 3x squared minus 4x minus 4. Okay, so the factorization looks quite tricky, but it's indeed possible. So certainly if you don't feel that you can factorize it, simply use the quadratic formula. But then for this one over here, you could use this alignment. So it will be 3, 1, and positive 2 and minus 2. So the crisscross sum is going to be minus 4 and precisely this guy. So this will tell me that 3x plus 2 times x minus 2 equals to 0. So that way you get x equals to minus 2 over 3 or x equals to 2. Okay, notice that C is required to sit strictly between -2 and 2. So we could use this x equals to 2 as a solution. So the only solution we have, it will be -2 over 3. So the conclusion is C equals to -2 over 3 satisfies the conclusion of Rolle's theorem. All right, so that concludes number 6. Okay, let's look at number 8. So we need to do a similar thing. So we need to verify this functions defined on this interval satisfies all the 3 hypotheses of the Rolle's theorem on this given interval. Then we need to find all the numbers satisfying the conclusion. So this is no longer a polynomial function, but since the interval is very nice, so we could still give a justification as follows. So x is continuous and differentiable everywhere. And 1 over x is continuous and differentiable on, well, 0 to infinity. So because we know that, well, any intervals inside the domain of this function, well, will make the function to be continuous and differentiable as well. So this will tell me that x plus 1 over x as a function is continuous and differentiable on the large interval 0 to infinity. But notice that this is not my f of x. My f of x is not the same function. My f of x is just defined to be this function when x sitting between 1/2 and 2. So this will actually imply that my f of x is continuous and differentiable on 1/2 to 2. All right, so that will finish the tracking. Okay, so this is how we track the first 2 hypotheses of the Rolle's theorem. And for the remaining one, all we need to do is compute. So f of 1/2, so this is going to be 1 over 1/2 plus 1/2. So this is going to be 2 plus 1/2. And let me be lazy not to compute it because I can see the f of 2 is going to be equals to 1 over 2 plus 2. And you see that they are precisely the same thing. So f of 2 equals to f of 1/2. So this is how we see that the third condition also holds. So that Rolle's theorem applies. And it will imply that there exists a C sitting strictly between 1/2 and 2, such that f prime of C equals to 0. And now let's try to find this f prime of C. Again, all we need to do is to solve the equation f prime of x equals to 0. But f prime of x is simply going to 1 minus 1 over x squared. And then let's actually write it as x squared at the denominator, and then x squared minus 1 on top. So this guy equals to 0. This means x squared minus 1 equals to 0. So x equals to plus minus 1, but we do not really need the -1 because -1 is sitting outside. So the conclusion is C equals to 1 is the only number satisfying the conclusion of Rolle's theorem. All right, so this concludes problem 8, and this also concludes this probably already very long supplementary video.